diffraction of X-rays by crystals. So crystals acts as 3D grating to X-rays. The wavelength of the wavelength of X-rays is very small compared to visible light. Compared to visible light. Hence, an ordinary diffraction grating cannot be used to measure it. Cannot be used to measure it. Okay. Lave found that. So scientist name Lave found that crystal an account of regular arrangement of atoms or molecule in it acts as suitable diffraction grating for diffracting X-rays. So crystals acts as diffraction of X-rays by crystals. Crystals acts as 3D grating to X-rays. The wavelength of X-rays is very small compared to visible light. Hence, an ordinary diffraction grating cannot be used to measure it. Lave, this is scientist name, found that crystal an account of regular arrangement of atoms or molecule in the it acts as suitable diffraction grating for diffracting X-rays. Next, experimental arrangement of Lave method. So this is crystal. So photographic plate. Photographic plate. S1, S2 slits. So this is the experimental arrangement of Lave method. So S1, S2 slits crystal photographic plate. So the X-rays from source are made into a parallel beam by passing through slits S1 and S2. Through slits S1 and S2. After passing through the crystal, after passing through the crystal, after passing through the crystal, the X-rays are diffracted and recorded on photographic plate. Most of the rays passed straight through the crystal and form a central black spot on photographic plate. So the X-rays from source. From source, the X-rays are made into a parallel beam by passing through slits S1 and S2. In diagram already we see S1 and S2 slits passing through the slits. X-rays convert into a parallel beam. After passing through the crystal, the X-rays are diffracted and recorded on photographic plate. Most of the rays pass straight through the crystal and form a central black spot on photographic plate. So with this experiment, with this experiment, conclusions are two conclusions are made. So first one, X-rays are X-rays are electromagnetic waves electromagnetic waves of extremely short wavelength. Second point, the atoms in a crystal are arranged in 3D lattice. So from this experiment, we have two conclusions that are X-rays are electromagnetic waves of extremely short wavelength. The atoms in a crystal are arranged in 3D lattice. So in photographic plate, we have black spot. Like this. Next, Bragg, scientist name, this is also Bragg discovered Bragg discovered that X-rays can be can be regularly reflected by planes of a crystal when the rays when the rays incident on surface at glancing angle. So Bragg, also scientist named Bragg, discovered that X-rays can be regularly reflected by planes of a crystal when the rays incident on surface at glancing angle. So this is the experimental arrangement. So this is crystal. Here we have S1 and S2 slits. So this is source. From source X-rays traveling from here and through the S1 and S2 slits. Here X-rays convert into parallel beam and incident on crystal NaCl. After passing through the crystal, X-rays are diffracted and recorded on photographic plate. This is photographic plate. This is photographic plate. So from this experiment, X-rays are electromagnetic waves of extremely short wavelength. Electromagnetic waves and short wavelength. The atoms, second point, the atoms in a crystal are arranged in 3D lattice. These two are conclusions of this experiment.